We are PreDent, a progressive web application that uses machine learning to promote safer driving by predicting car crash hotspots. Car crashes remain the leading cause of death for people under 30, meaning it is incredibly important to address this problem. We noted that most solutions combating this problem focus on driver education and safety instead of addressing the actual roads themselves. Thus, we took a unique approach from the Common Hackathon project. Instead of creating an application meant for general use, we developed an application specifically for state and city governments. We plan to implement our software as part of a nationwide governmental plan to promote safer driving and smarter road design, while still catering to the general drivers. The core of our project is a machine learning model that inputs static features such as speed limits, road signs, road curvature, and traffic volume, as well as weather, which are continuous features, and many other attributes to ultimately output a map of city roads with hotspots of where collisions are likely. Let's go to the government page. First, government officials can upload a CSV file of their collected traffic data, which many already have in private storages. This file is uploaded to Google Cloud, and we then input it into our model. The model uses previous crash sites, road features, and continuous features to make accurate predictions. Prepping our training set included aggregating both static and continuous features into one CSV. Tuning hyperparameters was a challenge since there were lots of different inputs, which ultimately ended in just 2 outputs. We trained with many batches and epochs, and we trained each model 3 different times. Ultimately, after training a gradient boosting model and a neural network, we found that the gradient boosting model had better metrics. Once we finished processing their data with our model, we notified them via email. Our model then outputs 1. A heat map with crash hotspots, 2. Coordinates of crash sites, and 3. Specific issues at each crash site. Using the model-generated coordinates, we create an interactive map using Google Maps API. At each pin, our model explains why that area was marked as high risk. With this information at hand, city designers can informatively improve their roads by determining where to fix roads, where to add additional signs, where to adjust speed limits, and more. This is essential for creating safer roads and thereby preventing fatal crashes. Let's go to the driver's page. Residents in partner cities can view a map with the hotspots of where crashes are likely in their city. This allows them to make more informed decisions about which areas to avoid or where to be cautious, improving safety. These heat maps change based on an hourly basis and time of year to account for rush hours and temperature and weather. Residents can also improve the efficiency of our model by inputting data about crashes in their neighborhoods by interactively placing pins on the map. Once they input latitude and longitude, they can drag around their pin for more accuracy. This allows residents to directly contribute to improving driver safety in their neighborhoods, while also allowing our model's accuracy to improve due to the extra data. Lastly, we have a data visualization page where we show our process of analyzing data and determining which factors are important, accompanied by lots of informative visualizations. We coded the entire app in 4 languages: HTML, CSS, JavaScript, and Python. After reading documentation, we developed our model and tested it on open source data from Utah roads, which we found on Medium, and produced the heat maps. We collected continuous data by scraping weather and road infrastructure databases. We used GeoPandas and Fiona to render these images. Instead of just uploading plots and graphs, we rendered our data into dimensional visualizations and maps as well, where we took the next step in just from previous just plots. We documented all our progress in Jupyter Notebook, which we recommend reading. This has been PreDent, and we hope to have a significant impact on driving.